All right, so this is going to be kind of fun. This is something new. So just a little review of everything that we've done so far this year. We've done linear functions. So we know linear functions are y equals mx plus b. So these are our lines, okay? Positive, negative slope lines. We've done quadratic functions. We know our quadratic function is y equals x squared. We've done our cubic functions, so y equals x cubed. And we know what all these shapes are because you have graphed them all. We've done our square root functions. That's this guy. We've done our absolute value functions, which is our v's. Down here, we've done rational functions. So this needs to come up here too. We've done rational functions. That's 1 over x. And that's this guy with our asymptotes. And now we're going to do these two functions, exponential and logarithmic functions, together. And the reason why we're going to do them together is because they're inverses of each other. And when we can do one, it's easy to go back and do the other one. So here are the two new ones. So our exponential functions, we're going to use b to the x equals a. And b here is going to be my base. All right, and then this is going to be log to the b of a equals x. And again, this b is going to be this b. This is the base. So when we have this b and this b, it's the same b. This a and this a is the same a. And this x and this x is the same x. That's why these work together. All right? So the b is always going to be our base, and our a is going to be our answer. Okay, so because these go back and forth and all of these are together, we say that exponential and logarithmic functions are inverses. They're inverses of each other. So we would undo one to do the other one, just like multiplication and division are inverses of each other. All right, so what does this look like? So we have to identify what we have here. And what we have when we look at this is my base. The base is whatever the bottom number is that has the power. So this is my base, and this is my answer. So if I take 5 and I square it, so x is my exponent, and let me just add that up here. So x is going to be my exponent. So if I have b squared, so 5 squared, it equals 25. So think about that. So this is the base. This is the exponent. 5 squared equals 25. 25 is a, which is my answer. So in my logarithmic form, if I was going to write it over here, I would have log of my base, and my base is 5. Now this is a little subscript. So it's a subscript, and that's going to equal my answer. And that's not a subscript. And that here becomes my x. So I took all of the same components that I had here, and I put it here. So this is b to the x, right? So this is my value of x over here. And this value of x over here, actually, let me just go ahead and put this in here. This should be a 2. All right, so again, I'm going to identify this. This is my base right here. This is my answer, and this is my exponent. So I'm going to have log base 10 of my answer, which is 1 over 100, equals negative 2. Now, this is my base, so log base 49 of 7 equals 1/2. Now, I don't know if you're hearing how I say that, but let me say this again. When I do this, this is going to be log base 49 of 7 equals 1/2. So if we go backwards, this is my base, log base 2. So log base 2 of 16 equals x. And what you're going to see me do is when we go from logarithmic to exponential form, I call this popcorn sometimes. So I start the 2, I go to the 16 equals x. 2 to the 16th power equals x. Okay, now this one is a little bit tricky, and this is tricky because there's no base, but there is a base. So we have, when there's no base given, common log is going to be base 10. And this is when no base is given. Now, the reason why this is called common log is because on our calculator, we have a log button and we have an ln button. What you don't see from these buttons are something that looks like this, log base 49. So when we have this and we have just log, we say that this is log base 10. So I'm going to rewrite this guy, and it becomes log of 10, log base 10 of q equals n. And when I popcorn this out around, I get 10 to the n equals q. All right, so super important, common log. So if we see this log, this is the same as log base 10. All right, let's flip it over. All right, so generally speaking, a log is an exponent. So it is an exponent. So we have some shortcuts. So our first shortcut is, since we know x to the 0 equals 1, or 5 to the 0 equals 1, then what we can say is log to the x of 1 equals 0. Now, here's why. I'm going to popcorn this guy out again. X to the 0 equals 1. X to the 0 equals 1. So what we have here is that this anything that's going to equal 0 that's a log is always going to be equal, or sorry, anything that has 1 here in your answer is always going to be equal to 0. So log 4, this is going to be 0. With this one, when I have log base x of 1, this is still going to be equal to 0. And if I was to do this, this is why. So before I wrote this, I could have popcorned this, and I could have said 4 to the x equals 1. Well, what is the only thing that's going to make a 4 equal 1? That's when this x value equals 0. And when the x value equals 0, then we know 4 to the 0 equals 1. Okay, same thing here. X to the 0 equals 1. What's the only thing that's going to make this equal 1? When x equals 0. Okay, so another rule that we have is if we have log base b of b to the x. So here I'm saying log base b, and this is my b, then this is going to equal x. Now, what it's really going to equal is whatever this exponent is. Now, what happens here, and this is what we have to look for, you have to have your log base equal your base. So here's my log base equal my base. All right, so let's do this. So if I have this one, log base 2 of 2 to the x, these are the same. Because if they're the same, my answer is my exponent. All right, log base 3 of 3 to the x, because these are the same, my answer is my exponent. Now, this one's a little tricky. Because they're inverses, this is saying the same thing. This is a base of 5, and this is a log base 5. So because of this, we know that the answer here is just x. All right, so we look at this and we say log base 2 equals 8. Well, these aren't the same, but I can make it the same because I know that 8 is the same as 2 cubed. And now I have log base 2 of a base 2. So these are the same, so my answer here is 3. So sometimes you have to manipulate this value right here to get the base that you need. In fact, we're going to do that often. Okay, last one. So 7, log base 7, these are the same, so my value here is just going to be 3. All right, so here's some more examples. In fact, I'm going to pause the video and I want you to work these 4 examples and then we'll come back. All right, so let's test this, see how you did. So here, base of 4, so my answer is just 3. These are not the same, 4 and 64 are not the same, but I can turn a 64 into a 4 by saying 4 cubed. Now, these are the same, so my answer is 3. All right, 5 and 1 over square root of 5 are not the same, but I can make this be a base of 5 because this is a negative 1/2. So now these are the same, so my answer is just negative 1/2. Now when I look at this, I have a 10 and a log 9. There's no base here, but I can make this a base because remember this is our common log and a common log is a base of 10. So now I have 10 to the 10, so my answer here is just 9. Okay, I'm going to give you lots of these to practice, and so hopefully you'll start seeing these patterns. Okay, so let's go through these. So log base 9 of 1. We already said anything that equals 1 is always going to be a 0. All right, these two values are the same, so this is going to equal 1. These are not the same, but I can make them the same because I can make 27 is 3 cubed. So this becomes a 3. These are the same, so this is a 1. These aren't the same, but I can make it the same because this becomes 7 squared. 7 squared is 49. So now I can cancel those out, and this becomes a 2. This guy is the same thing. So 49, to get it out of the denominator, though, it's 7 to the negative 2. So this becomes negative 2. All right, now with this one, I have 49 and 7. Well, I can't change the 7, and I can't change my base. So I am going to use this popcorn method here, and I'm going to say 49 to the x equals 7. So 49 to the x equals 7. So we know this. You have to think about it just a little bit. But if I took the square root of 49, it's going to equal 7. And how do I make this exponent a square root? I'm going to say x equals 1/2. X equals 1/2 is the same as the square root of 49. Okay? So we can't change the base. We can't make the base 7 squared. We can't do that. But what we can do is say, all right, this becomes, how do we get 49 to equal 7? We take the square root. All right, so if we use that logic and we come down here, then this guy is going to be negative 1/2 because I've got to get it out of the denominator. All right, so how do I turn a 3 into a 9? So 3 to the x equals 9. I square it. So if I square it and move it to the denominator, I have negative 2. All right, let's look at this guy. I'm going to make this an x for a minute. 9 to the x equals 3. How do I make a 9 equal a 3? Well, again, I take the square root of 9. That equals 3. So my value here is going to be 1/2. Base and base are the same, so this equals 1. Base and base are the same, so this equals negative 1 because I have to get it out of the denominator. All right, so now we're going to do these problems, and these problems are called next level. So this is kind of the next level of what we're going to look at here. And with this, we're going to want to popcorn this. So I have this 49 and x. So 49 to the x equals the square root of 7. So if I write this, 49 to the x equals the square root of 7. Now the goal here on all of this is we have to have same base on both sides. So how do I make this 49 a 7? Well, to make this a 7, I'm going to say 7 squared, but I still have this x, so the x has to stay. And how do I make this a 7? I'm going to say 7 to the 1/2. So let me pause there for a minute. I took 49 and I made it 7 squared. But since I already have an exponent, I'm going to multiply these two exponents together. Now with this one, I have a 7, but square root of 7. I don't want the square root. I want just a 7. So to get rid of the radical, I make it an exponent. So now, because this base and this base are the same, at this point, we set the exponents equal to each other. So what does this mean? It means 2x equals 1/2. Then I solve for x, so I divide both sides by 2, and I get x equals 1/4. All right, let's try another one like that. So this is a little bit different. So I'm going to set this equal to x, and I'm going to popcorn this guy. So 27 to the x equals 9. Well, there's nothing I can do to make a 9 equal a 27. I can't say times 3, because remember what I'm doing is I'm looking at an exponent. So you always want to, with all of these, you're going to reduce to the lowest term. All right, so what do I know about 27? Well, 27 is 3 cubed. 3 times 3 is 9. 9 times 3 is 27. So this becomes 3 cubed times x equals 3 squared. Now, I have same bases, so all I do is put my exponents equal to each other. And remember, I'm solving for x, so x equals 2/3. All right, let's go on to the next one. I popcorn this out, and I have 27 to the x equals 81. So nothing I can do here. I want to bring all my bases down. So I'm going to say 3 cubed is 27, so 3x. And this is the same as 3 to the 4th. Now, again, that's why it's really important to know these. If I have 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So now I have same bases. So I have 3x equals 4. So x equals 4 over 3. So again, your multiplication is going to be super important on this. Okay, so this gives me 8 to the x equals 32. And I'm looking for same base. So this is going to be 2 cubed. 2, 4, 8. All right, and on this side, I can keep going, and I'm going to have 2 to the 5th power. 2, 4, 8, 16, 32. Same bases now. So I have 3x equals 5, so x equals 5 over 3. Okay, just a couple more. All right, so this is super funky. This is a decimal. So what I have here is I'm going to take this value and I'm going to set it equal to x, and I'm going to popcorn this out. So I have 0.01 to the x equals 1,000. And you're like, whoa, how do I make that happen? Well, what is this? This is your tenths place and this is your hundredths place. So that's like saying 1 over 100 to the x equals 1,000. All right, so we're getting closer, and we're getting closer because hopefully what you see is that you can make this a base of 10. So if I make this a base of 10, so 10 squared is 100, but it's in the denominator, so 10 to the negative 2x. All right, and on this side, I'm going to have 10 cubed. 10 cubed is 1,000. And so while this looks awful, if you just take this to what you know, which is a fraction here, 1 over 100 equals 1,000, then x is going to be negative 3 over 2. Okay, let's do one more that looks like this. So this equals x, so 100 to the x equals 1,000. And this one's actually way easier because I know this is 10 squared, and I know that this is 10 cubed. So I have a positive 3 over 2 this time. Okay, so I'm going to go ahead and pause the video, and I want you to work 24 and 25 and then come back. Okay, here's what we have. Here's my two answers. So if you've got these, you can go ahead and disconnect. If not, let's talk about this. I cannot make this a base of 4, right? So this is a common mistake. So this is not a base of 4. So 4 squared is 16. But I can't make this a base of 4, right? So if I make this 4, I mean, there's no way for me to make this equal 8, right? So I have to go all the way down to a 2. So 2, 4, 8, 16, that's where the 4 comes from. And then this is 2, 4, 8. Same base, set it equal to each other. So in this one, I end up with this fraction. Again, I can't make this 4 times 2 because it's not. It's 4 squared. So the only way I can make these have the same base is go all the way down to a base of 2. All right.